Hi guys, welcome back to our YouTube channel. My name is Anji Gaur. Now I am going to explain you trigonometry. Okay, so this is the 11th chapter in our mathematics subject. So trigonometry is our chapter name. Okay, so basically what is trigonometry? So trigonometry is a branch of mathematics. It is a branch of mathematics. Branch of mathematics which deals with the mathematics which deals with the relationship between between sides and angles of a triangle. Am I clear? So this is a basic definition of the trigonometry. What is the basic definition of the trigonometry? Trigonometry is a branch of mathematics which deals with the relationship between sides and angles of a triangle. So we are going to measure the sides and angles in this trigonometry. Am I clear? So see here. Now what is given in our first chapter in the first page? Here introduction. So see the introduction. So here one pole is there. That pole is erected by one rope, right? So this pole and rope are stand on the base ground. Yes or no? Yeah. So this pole is stand with the 90 degrees. Yeah, it's right. It is standing with the 90 degrees. Whereas, sorry. So whereas this rope is made an angle to the rope with the ground. Yes or no? See, you can see here. Yes, it is right. You can see here. This is the angle. Here, angle is made by the rope to the pole. So this is certain elevation is there here. So this is a ground. Okay. So it is like triangle. Yes, if you consider this as a triangle, one triangle. Yes or no? This pole is one side, and your base is the ground, and this rope is another side. So we are framing one triangle with this. Yes or no? So here given so many examples. We will go with the examples. So make me to remove these all things. So see now. So here a person is whitewashing a wall with the help of ladder. See now this how he placed the ladder. It is very opposite to the wall. The wall is with 90 degrees. Yes or no? It is making a angle 90 degrees with the ground. So whereas this ladder is making an elevation, right? So here this is the theta. Yes, this is the angle made by the ladder here. Yes or no? So this is the angle made by the ladder. So now you can see one more example here. So see this example. So in this example, what is going on here? In a playground, children like to slide on a slider. Here, see the slider. How is the sliders? How is the slider? How is the slider angle? See now. So if you consider this as one triangle, yes or no? Yes. So if you are imagine this, we get one triangle. Here elevation is made by this slope. Yes or no? This slider. So in the same manner, we given examples for this. So wait a second. Yeah, right. So those are the examples. See, if you want to whitewash the higher point on wall, what should you do? You have two ladders, ladder A and ladder B. For suppose these two ladders there, same ladders. Okay. Now, if you want paint on higher elevation, higher side. So what you will do here? You have to make a different angle with the ground. Yes or no? See now. See here. I'm just give me a minute. So yeah, it's okay. Right. Now see here. This is a ladder. So for suppose you see it is with the angle. For suppose 30 degrees, it is making an angle. So here elevation is 10 centimeters, for suppose 10 centimeters height this is. So if I given the slope, if it is making the angle the 45, so it is up to 7 centimeters. So when the this one slope is increasing, the height is decreasing. Yes or no? You can observe this. So with the same ladder, so the ladder height is same, but the elevation, angle of elevation is different here. Yes or no? Yes. So we will go with this text once. What is the text given here? So we go with the text. So if a person wants to whitewash at higher point on the wall, what happens to an angle made by the ladder with the ground? Okay. So next, what will be the change in the distance A and B? So what is the distance between A and B? A and B is distance is increasing when the height is decreasing. Yes or no? When the height is increasing, the distance between the A and B will be decreasing. Yes or no? We will observe from this point. So next, if the person want to whitewash at lower point on the wall, what happens to the angle made by the ladder with the ground? This is the angle made by the ladder. When the person wants to whitewash the lower point in the sense downside, this here point C. So what is the angle is changing, right? So what will be the change in the distance AB? Now angle is changing, at the same time distance also changing. Yes or no? Yes, we will observe this point from this. So we have observed the above example person who was whitewashing when sorry when he want to paint at higher or lower points, he should change the position of ladder. Yes. So when theta is increased, the height also increases. When theta is increased, height also increases, base decreases. See, note this point. What is the point given here? When theta is increased, height also increases, base decreases. What he is saying, when theta increases, theta is nothing but angle increased, height also increases. Yes or no? Height also increases, but base decreases. So this is a thing we have to know from this point. So okay, next. So next, see here. So here when we have sorry, we have seen the right angle triangle ABC. Now let name side again, because trigonometric ratios of angles based on sides only. So this is the main point. So what is the main point here? The all trigonometric ratios are depends upon the sides only. Okay, depends upon the sides. Trigonometric ratios all depend upon the sides. So next, so naming the sides of a right angle triangle. So it is very important how we name the triangle. So I am going to the workbook right now. See, this is completed, right? So the definition of the basic definition introduction is completed. Now we are entering into the trigonometric ratios. Trigonometric ratios. So now trigonometric ratios. So see here, first I am going to take one a right angle triangle here. Right here I am going to take one right angle triangle. Yeah, it's my right angle triangle. So I am naming the sides. This as A, this as B, this as C. Am I clear? Right. Now A, B, C sides are given, right? Now what should I do? I am naming the side. This side is, what is this side? This is opposite. Okay, this is opposite side. Opposite side. Next, this is adjacent side. What is the side name? Side name is adjacent side. And now this is hypotenuse. What is this? Hypotenuse. Yeah. So I given the sides and its names. Am I clear? Yeah. So I am writing the here. AB is AB equals to what? AB here? Adjacent side. AB is adjacent side. Adjacent side. Don't confuse. For your clarity, I am explaining each and everything from the base level. So now what is BC here? BC is equals to opposite side. BC equals to opposite side. Opposite side. Now what is AC? AC or CA, anything. Sorry to say. CA or AC, your wish. That is hypotenuse. Hypotenuse. Yeah. So in triangle ABC, in triangle ABC, so in right angle triangle ABC, AB is the adjacent side, BC is the opposite side, and AC is the hypotenuse. Am I clear? Right. Now moving to trigonometric ratios. So remember here, basically there are only you have to remember first three, then we will get another three easily. So first I am going to explain you three. That first one is sine theta or sine A. Okay. So this is considered this is the angle A. Okay, right. Now sine A equals to what? This is our first question. Our trigonometric formulas are starting from here itself. Okay. Now, what is sine A is? Sine A is nothing but your opposite side by hypotenuse. What is your opposite side? That is BC. Your opposite side is BC by hypotenuse. What is hypotenuse here? AC or CA. Okay, you can write as CA. Hypotenuse is here, CA. Both are same. Okay, no issue with that. Next, this is what sine A equals to opposite by opposite side of angle A. This is a full, okay na? Angle A. Opposite side of angle A by opposite side of angle A by hypotenuse. Okay, hypotenuse. So this is your sine A formula. Remember clearly. So you should remember till entire the chapter. What is sine A? If someone asks you, what you will give the answer? Sine A is nothing but opposite side by hypotenuse. Simply we can write as opposite by opposite by hypotenuse. Opposite by hypotenuse. Am I clear? So you can write simply like this. Next, what is the next thing? Our next thing is cos A. So it is very easy. What is cos A? You know already. Cos A formula is now opposite completed. Next one is adjacent. Adjacent what? AB. AB by adjacent is AB and hypotenuse is CA. So cos A formula what? Cos A formula is adjacent by adjacent side of angle A. Adjacent side of angle A by adjacent side of angle A by hypotenuse. Okay, hypotenuse. Yeah. So this is your cos value. Remember clearly. Okay, I will say one more time. What is cos value? Cos A is adjacent side by hypotenuse. Adjacent side by hypotenuse. Next one is your third one, that is tan one. Okay, so we are going with the tan. So tan A. Okay, I'm going to write tan A equals to tan A is opposite by tan A is opposite side of angle A. Opposite side of angle A by Opposite side of angle A by opposite side of angle A by adjacent side of angle A. What is adjacent side of angle A? Am I clear? So what is opposite here? BC. Okay, BC. What is adjacent here? AB. So your tan A formula is this one. Okay. Remember these three formulas. We can derive another formulas very easily. So if you remember this, then we will derive another formulas very easily. So this one is your tan A. What is the tan A value? Opposite side of angle A by adjacent side of angle A. Am I clear? So these are the three basic trigonometric ratios. With these three basic trigonometric ratios, we can derive another three. Okay, let us see that one. So now see, first one is cosec. Cosec A. What is cosec A and sec A? And one more thing is that cosec A, sec A, and the last one is cot A. Cot A. These three are very important. Okay. Now I will say you very easily how to derive these formulas. See now. So sine reciprocal, the multiplicative, sorry, sine multiplicative inverse is cosec A. Cos multiplicative inverse is sec A. Cot multiplicative inverse is tan A. Tan multiplicative inverse is cot A. Okay. Now it is very easy that there is just multiplicative inverse. We have to just write down here. See now. Yeah, just write down. What is cosec A means 1 by sine A. Your formula is completed. Now what is mean by 1 by sine A? Just quite opposite to sine A. So what is cosec A means? Opposite to sine A. That is nothing but your hypotenuse by opposite. This is very easy, right? Opposite. Hypotenuse by opposite. This is your cosec formula. What is cosec? Reciprocal of sine. Okay, na? Next, what is sec A? What is sec A? Sec A is very easy. 1 by cos A. 1 by cos A. So that is very easy. 1 by cos A. What is 1 by cos A? 1 by cos A is nothing but, see here, reverse of cos A, that is hypotenuse by adjacent. See here, opposite, quite opposite. Yes or no? Both are quite opposite. Okay, no? Next, sec A is also completed. If someone asks you what is sec A formula, sec A formula is hypotenuse by adjacent. What is cosec A formula? Cosec is hypotenuse by opposite. Cosec. Next, last one, cot. So what is cot? Your cot is nothing but tan A multiplicative inverse is cot. So I can write as your cot is adjacent by hypotenuse. Adjacent by hypotenuse. Adjacent by hypotenuse. That is nothing but 1 by cot A. Sorry, 1 by tan A, right? 1 by tan A. It is very easy. 1 by tan A. 1 by tan A. They are reciprocal, multiplicative inverse. Okay, na? So these all are multiplicative inverse. You are simply remember. So cosec means 1 by sine. Sec means 1 by cos. Cot means 1 by tan. So if you remember like this, then you never forget these six formulas. You should remember these six formulas entire for till the entire chapter, end of the entire chapter. Okay. So these are the trigonometric ratios. Now let us find simple example. Just I'm taking one triangle here. I'm taking right angle triangle. A, B, C. Okay. Now this is theta. Now for suppose this A is 6 centimeters, B is 3 centimeters, and what about this AB question mark? So very simple. Whenever you are getting two sides value, you have to find the third side value. Yes or no? You have to find the third side value. How to find the third side value? So with the help of the sorry, with the help of the Pythagoras theorem, with the help of the with the help of Pythagoras theorem, so with the help of Pythagoras theorem, so with the help of Pythagoras theorem, we are going to find the this unknown value. Let us, what is Pythagoras theorem actually? Pythagoras theorem is nothing but sum of the two sides, sum of the two sides, sum of the squares, okay, sorry, sum of the squares, sum of the, yeah, sum of the squares, sum of the squares of two sides, sum of the squares of the two sides equals to square of the hypotenuse, square of the hypotenuse or hypotenuse square. What I told you here, sum of the squares of two sides is equals to hypotenuse square. So what is hypotenuse here? BC is hypotenuse, right? So now BC is hypotenuse, nothing but BC square is equals to, what we can write here? BC square is equals to AC square plus AB square. Yes or no? So for if your triangle is different, we can write one more like this also. See now, for suppose if you take the right angle like this, so the normal we will get like this. Yes. So now this is A, B, C. For suppose if the right angle at B, then the formula is, what is hypotenuse here? What is hypotenuse here? Hypotenuse. This is opposite and this is adjacent. So you don't forget the what is Pythagoras theorem. Okay, you remember the Pythagoras theorem, then you definitely get the solution. What is Pythagoras theorem? Sum of the squares of the two sides is equals to hypotenuse square. So what is here? Now I change the triangle here, right angle triangle. I kept the right angle at B now. Here in the last example, I kept the right angle at A. Yeah, right. Now in the triangle ABC, we can write the, according to Pythagoras theorem, AC square equals to AB square plus BC square. Yeah, it is right. So AB square plus BC square is equals to hypotenuse square. So it is depends upon the diagram. Okay, you remember this is we how we get only depends upon the diagram. That is nothing but your triangle shape. Okay, but basic thing, this is the basic one. Okay, sum of the squares of the two sides equals to hypotenuse square. Now our job is to here find the unknown value, right? So now see. So let us draw the one triangle with the same, yeah, okay. Yeah, this is one triangle A B C. So hypotenuse is given, that is 20 is sorry, okay, we take the smaller values. So hypotenuse is 10, side is one, opposite side is 5 centimeters. Now this is what AB is, what question mark. Okay, now we need to find AB. So how to find AB here? See now, according to Pythagoras theorem, what is AC square is equals to AB square plus BC square, right? AC value we given. AC value is here 10 centimeters and AB value is here unknown value, we can call it as x centimeters. Okay, let us consider x centimeters. Now BC equals to 5 centimeters. Okay, now we are going to find the unknown side, that is AB. What is the AB? Now AC square is nothing but 10 square equals to AB square is nothing but x square plus BC is equal to 5 square. 10 square is 100 equals to x square plus 25. 5 square is 25, right? Now 100 equals to x square plus 25. So now what you will do? The send this 25 that side. Then x square equals to 100 minus 25. Yes or no? Yes, it is right. 100 minus 25. That is, I want to move upside. So now see here. So right, yeah. Now x square equals to 100 minus 25. What? 75. Yes, it is right. Yes, it is right. Now x equals to root 75. X is equal to what? X value is root 75. So now we, what is the unknown side of the AB? AB side is equals to root 75. Clear? So in this way we are going to find the unknown value. Okay, unknown side. So with the help of the Pythagoras theorem, we use the Pythagoras theorem in the chapter so many times. Why? Because we have to find the unknown side. One unknown side is we have to find. So we use the Pythagoras theorem. So now let us enter into exercise. Okay. See now, I forgot to say this. So what is here? Now, once we go with the textbook, what is given in the textbook here? So in the textbook given naming the sides in a right angle. So what we discussed up to now, it will be given in the same format. Just we will go through with this content too. Yes, okay. Now let us take the right angle triangle ABC as shown in the figure. This is a right angle triangle. Okay. So here angle A it is here, making angle A at right angle at B, and this is C. So here what is hypotenuse here? This is AC is hypotenuse. What is BC here? This is opposite. What is this opposite to which one? Which angle? This is opposite to angle A. Remember this with the reference to the A. Okay, with the reference to the angle A, this BC is opposite. With this BC is opposite. For suppose with the reference to the angle C, which is opposite. Did you got my point? Okay, I will. So see here. So now, so where is the pencil? Yeah, it's okay. Now with reference to the angle C, with reference to the angle C, what is opposite? So that is your opposite side with respect to the angle C is angle AB. This is your opposite side with respect to the angle C. With respect to the angle C, what is adjacent? This BC your adjacent. Your BC is adjacent. Don't forget, this is very important. Why? Because you may confuse with this, but you are not going to confuse here. So I am explaining very clearly. So if first suppose with respective to the with respective to the angle C, this one angle C. So what is opposite? Opposite side is AB. Opposite side is AB. Now what is adjacent? So what is adjacent here? Adjacent is BC. Adjacent is BC. So what is your hypotenuse? That is your hypotenuse is AC. So hypotenuse never going to change. Okay. So here opposite and adjacent are changed, but hypotenuse is same. Are you clear? So you have to compare the with respective side, we have to give the opposite and adjacent. Okay, so don't confuse here. So just I am, for your clarity, I am explaining this. So with respect to the angle A. So what is hypotenuse? AC is the hypotenuse. With respect to the angle A, what is adjacent? This AB is the adjacent. What is the opposite? BC is the opposite. Okay, right? So here remember one thing. This is a basic introduction class, right? So that's the reason I am explaining everything in a clear manner. So see now, defining the trigonometric ratios. Here I forgot to say here sin A. What is the spelling here? SINE, sin A. But we simply write as sin, SIN A. Okay, SIN A, sin. So this is sin A. Next, what is the sin A formula? Sin A is opposite by adjacent. Opposite by adjacent. So opposite by, sorry, sin A formula is opposite by hypotenuse, right? I am confusing. Okay, don't worry. So right. So this is sin A. Next, actual name of cos A is cosine. What is the actual name of cos A? Cos A is cosine. So don't forget when you get the term cosine means what you don't see with the blind faces. This cosine is nothing but your cos A. Okay. We call them as cos A. But what is the actual name? Cosine A. Okay. Next. So this is all I explained in the with simple examples. So it is okay. Next, ratios of the right angle, right here. See, sine is nothing but SINE, sine of angle A is SINA, sine A. Next, cosine, COSINE, cosine cosine of angle A equal to cos A. Okay. So next, tangent. Tangent we can simply call as tan A. TANGENT. Tangent of angle A we simply call as tan A. Here cosine A is nothing but cos A. Sin A is nothing but sin A, right? So next, a few more there. Three are there. Remaining three we will learn. So right here. So what is the cosec formula? 1 by sin A. What is sec formula? 1 by cos A. What is cot formula? 1 by tan A. So here already these names also given here. Cosec is nothing but cosecant. Cosec is nothing but your cosecant. We shortly call as cosec. Cosec A. This is right. Now the then cos. Cos is a cos not secant. Secant we simply call as sec. Simply written as sec. Secant we simply written as sec. Okay. So don't remember, don't confuse with these names. Next, cotangent. Cotangent we simply call it as cot A. Are you clear? So these are the basic things you don't forget. So with this we shortly call as cot, tan, sin, sec, cosec. Now I am going to explain you how to derive the ratios, some important values of some important angles of the trigonometric ratios. I have one simple trick. So if you follow this trick, you never forget the values of the angles, trigonometric ratios. Okay. So now first angles are 0 degrees and 30 degrees, 45 degrees, 60 degrees and 90 degrees. So now sin A. First you write simply 0, 1, 2, 3, 4. Okay. Next, what you do, just your second step is divide by 4. Divide every digit by 4. Every digit by 4. This is a very simple trick. So just for your remembrance, I am saying this. So see now, divide the every digit by 4, right? 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4. Yeah. Now, after completion of the division, next to your one more step, last step, that is put the square root, put the square root. square root for every digit, every number or every digit, whatever it may be, every number. Okay. Now, so just I want to drag upside. Okay, it's clear. Now put the square root for every value. Okay, every value. Right. Now square root, I am putting the square root for every value. 0 by 4, under root 1 by 4, under root 2 by 4, under root 3 by 4, under root 4 by 4. Yeah. Now see, just solve this, simplify this. What we will say, very it simplify just. Now root 0 is root 0 by root 4. So this is root 1 by root 4. Root 4 is nothing but, we will do it in the next step. Root 4. Next root, this is 2 1 ja, 2 2 ja. Root 1 by root 2. Next here root 3 by root 4. So root 4. Here 4 1 ja, 4 1 ja. That is root 1. Now the root 0 is 0. Now root 4 is 2. Okay. Next root 1 is 1. Root 4 is 2. Root 1 is 1. Root 2 is root 2. Next root 3 is root 3. Root 4 is 2. Next root 1 is 1. So are you observing what I am doing here? So now you have, if you don't know the values I am writing here, since root 0 is 0, root 1 is 1, root 2 root 4 is 2. Okay, if you don't know means I am writing here, these values are, these are the values. Okay, right. Now I want to go a little bit upside. Now see here, we got the final values of sine. You can observe here final values of sine, we are clearly see here. So 0 by something, what, 0. Yes, 0, right. So 0 by something, 0. Next 1 by 2, 1 by 2. Next 1 by root 2, 1 by root 2. Next root 3 by 2, root 3 by 2. That is 1 1. Okay. Now you can check your values of the sine. These are the sine values. You can check in your book also. These are the sine theta values. This is for theta is what? This is for 0 degrees. This is for 30 degrees. Sine 30. This is sine 45. Sine 60. And this is sine 90. Am I clear? So this is a very simple trick. You can try it. You can get the values. Now you got only sine values. So you need to find more 5 ratios are there, right? So it is very easy. If you find one ratio value, then it is easy to get the another 5 ratios. How? You can see here. I will explain you that one also. Now it is very simple to find. Yeah, I will start. So yeah, now I want to cos formula. Okay, cos theta values. So can you guess how to do this cos theta value? It is very easy if you remember one point. So just reverse it, you will get the values. Reverse in the sense, just write down 90 to 0. That is cos 0 is 1. Cos 0 value is 1. This is 1. Don't think as something. This is 1. Okay. Cos 0 value is 1. Right. Next, cos 60 root 3 by 2. Next, cos 45 is 1 by root 2. Next, cos 60 is 1 by 2. and cos 90 is 0. Is it clear? Just what I am doing here, just I am reversing the sign values. Yes or no? Yes. So just I am reversing the sign values, right? You can see here. So just as it is, this sin 45 cos 45 both are same. So just I am reversing the numbers. So don't confuse with the lines. These lines to help you understand. So just I am reversing the values. So with this we get everything very clear. Yes or no? Yes. So now we have to find what we have to find now. Tan value. Yes, tan theta value. So we already know what is the tan formula. Tan formula is sin by cos. Sin theta by cos theta. Yes or no? Yes. So tan formula is sin theta by cos theta, right? Now above sin is there, below cos is there. You can do directly write down. That is now tan theta value is 0 by 1 and 1 by 2 into 2 by root 3. Next 1 by root 2, 1 by root 2 into root 2 by 1. Next one root 3 by 2 into 2 by 1. Next this is sine 1 by 0. Sine is 1, cos is 0, right? Now you are going to do the, just simplify this. 0 by 1, what is 0 by 1? 0 by 1 is 0. Yes or no? Yes. So next, this is 2 to get cancel. What will here? That is root 3. Yes or no? 1 by root 3. Tan 30 is 1 by root 3. Tan 45 is 1. Tan 45 is 1. Next, tan 60. Tan 60 is here 2 to gonna cancel. Tan 60 is root 3. And tan 90 is 1 by 0. So you don't confuse here. See now, a little bit confusion will be there. So what we are doing, just we are writing sine value upside and cos value downside. Okay. So now here 0 by something 0, right? So it is mistake. Sorry. 0 by something 0 by something 0. Yes or no? Yes. So now it is 0 by something, right? 0 by something is 0. Yeah. Okay. So now see here, these values are very clear, right? So I jump into the, okay, right. Now next one is what? This tan 1. What is tan 1? Sorry, tan 90, right? Tan 90 is 1 by 0. What is 1 by 0? 1 by 0 is nothing but we can't define the value. Value is not defined. Value is not defined. So this is 0, right? 0 by 1, 0. So are you clear? These are the tan values. These are the tan values. Okay, you got tan values. Now we need to find what? Then we have to find cosec theta. Cosec theta is nothing but reciprocal of sine, sorry, multiplicative inverse of sine theta, right? So now multiplicative inverse of sine theta is nothing but 1 by sine theta. So 1 by sine theta is nothing but cosec. Cosec is equal to 1 by sine, right? Now 1 by 0. So 1 by 0 is not defined. Not defined. Not defined. Next, 1 by 1 by 2. See here, 1 into 2 by 1, that is nothing but, that is 2. So your cosec 30 is 2. Next 1 by sine 1 into root 2 by 1. Root 2 by 1, that is also nothing but your cosec 45 is root 2. Next, cosec 60, just you have to write 1 into reverse of sine, what? No, no, reverse of sine is 2 by root 3. That is nothing but your cosec theta is equals to 2 by root 3. 2 by root 3. Next, what is the next one? Next one is 1 by sine. What is the 1 by 1? 1 by 1 is nothing but 1. So your cosec 90 is 1. So check your textbook or anything, the values are correct or not. Yes or no? This is very simple. What we are doing, just we are deriving one sine value, then after we are just using the formulas and we are finding the other remaining ratios. Yes or no? Yes, it is very clear. You can check in the textbook also. Here I am checking the values. Cosec theta is 0 degrees is cosec theta 0 degrees not defined. So cosec 30 is 2. Yes, it is right. Cosec 45 is root 2. Cosec 60 is 2 by root 3. And cosec 90 is 1. Absolutely all values are correct. So you just uh, memorize the formulas, then you will easily get the all ratio values with the all angles. You don't need to by heart anything here. Yeah. Now we will find the remaining thing also, right? So we need to find, right? Okay. Our next one is what? Our next one is next thing is to find sec theta sec theta. Okay, sec theta values. So this is 0 degrees value. So I don't confuse here, 0 degrees and 30 degrees. This is 45 degrees, 60 degrees and 90 degrees. Am I clear? Okay, right. Now sec. Sec is nothing but 1 by cos. 1 by cos. You already know the cos value, right? Now 1 by cos. 1 by 1, 1. Now 1 by 1 is 1, right? Okay, for your clarity, I will write as it is. Okay, 1 by 1, 1. 1 by 1. Next. Next one, 1 into 2 by root 3. So 1 by cos, right? What is the cos 30 value? Root 3 by 2. Just reverse it. Okay, 1 into 2 by root 3. Next. What is your cos 45 value? That is 1 into root 2 by 1. Okay, just I am reversing. Why? Because it is reciprocal, right? 1 by cos. So I am reversing the value. That's it. Next, what is the next? Sec 60, that is nothing but 1 into 2 by 1. Next, 1 into what is that? Sec theta 1 by cos. 1 by cos is here what? Cos is 0, right? So 1 by 0. So we already know, yes or no. What is 1 by 0? 1 by 0 is not defined. So what are the values we got here? Just check it. Check it and we will check in the textbook too. Right. So 1 by 1, 1. Next one is cos sec 30 is 2 by root 3. 2 by root 3. Sec 45 is root 2. Sec 60 is 2. Sec 90 is not defined. Sec 90 is not defined. Yes, we can write as this symbol, infinity symbol also. Somewhere we will see these symbols also. Infinity, not determined. Okay. So this is your sec formula, sec values. Okay, the last one, but not least, it is also important. Last one is your cot theta, right? So we are going to find the cot theta values also. Your cot theta equals to now. So what is cot? Cot is nothing but 1 by tan. Cot is nothing but 1 by tan theta. So 1 by tan is nothing but here 1 by, what is the tan value? Tan 0, 0. So now 1 by 0, again what we will get? It is not determined. So it is not determined. Okay. Next. Cot, cot 30. 30. What is the tan 30 value first? Tan 30 is 1 by root 3. So cot 30 is nothing but 1 into root 3 by 1. That is nothing but root 3. Cot 30 is root 3. Next, what is a cot 45? Tan 45 is 1. 1 by 1 is 1. 1 by 1 is 1. Okay. Next, what is cot 60? What is tan 60? Tan 60 is root 3. That is very simple. 1 by tan is nothing but 1 by root 3. That is nothing but 1 by root 3. Your answer value is 1 by root 3. Next to the last one. What is cot 90? First, what is tan 90? Tan 90 is not defined, right? Tan 90 is not defined. Your cot 90 is, that is, first of all, 1 by, not defined means what? Not defined means 1 by 0. So that is in the sense 1 into 0 by 1. That is nothing but your 0 value. Okay, 0. Your cot 90 is 0. Check with your table. Is it correct or not? Cot value, cot 0 degrees is not defined. It is right. Cot 30 value, cot 30 is root 3. It is also correct. Cot 45 1, and cot 60 is 1 by root 3, and your cot 90 is 0 degrees. Every value is derived properly and correctly, exactly, yes. So whatever I am saying, you just apply that formulas, you will get the clarity without any doubt. Okay, so in this way you have derived all the formulas. Am I clear? Right. Now our next agenda is we are entering into the chapter exercise. Now, before going to the exercise, we do little thing what we discussed up to now. We just revise once and then we enter into the exercise. Why? Because if you once enter an exercise, we are going to solve all problems, right? So now, what we discussed up to now. So just see now. First, what we discussed, definition, right? Definition of trigonometry. Definition of trigonometry. And next, what we discussed, trigonometry. Yeah. Next, definition is completed. Next, then some examples, right? Examples of examples in the real life, right? In the real life, examples in the real life. Next, after examples, what we discussed, trigonometry, defined to definition, examples, ratios, trigonometry, naming naming the trigonometric ratios, uh, trigonometric trigonometric ratios. Yes. Next, then after naming the trigonometric ratios, after values for the values of some important angles, values of some important angles. Okay, important angles. Okay, next, Pythagoras theorem. With the help of the Pythagoras theorem, we find the unknown side. Pythagoras theorem, right? Next, uh, Pythagoras theorem we completed. So sine value sticks. Okay, how to find the sine value with a trick. Okay, so but last not the least, just I will explain you this small thing. Don't forget here. First, sine, SINE, sine. We simply call them as sine A. SINA, sine A. Next, cosine. Cosine, we will simply call it as a cos A. Cosine A is nothing but we simply call as cos A. Next, tangent. Next, with tangent we simply call them as tan A. Okay, tangent A is nothing but tan A. Next, cosecant. Cosecant means nothing but cosec. Cosec A. Okay, cosecant A is nothing but cosec A. Next, secant. Secant A is nothing but sec A. Next, tan. Sorry, cotangent. Cotangent. Cotangent is nothing but cotangent is nothing but cot A. So these are the short forms which we use. Okay, sorry, these are the short forms which we use regularly in the our problems. Okay, these are the short forms. Sine A, we shall simply write sine A, and cosine we simply write cos A. Tangent we simply write tan A. Next, cosecant, we simply write cosec A. Secant, we simply write sec A. Cotangent, we simply write cot A. So these are the six, yes or no? One, two, three, four, five, six. These six ratios are we use in the trigonometry, and with this with the six with the help of these six we form three identities. We learn in the upcoming classes. Three identities are there. Those identities play a very key role in solving the equations and problems. Okay, this is the end of the session for this. So thank you for watching. If anything in the content went wrong, so we will correct in the upcoming classes. So thank you for watching.